Okay, I think it's time for our first meetup to begin. So let's get started. Hello, everyone. Welcome to join Greptime first online meetup. For today's meeting, we invited Greptime's 3 technical co-founders. Dennis, welcome, Dennis.
Hello, everyone. Welcome to our online meetup.
Welcome, Dennis. So Dennis has 16 years of experience in the software development industry. His expertise lies in messaging middleware, backend as a service, time series data storage, and development of large-scale enterprise-level observability solutions. So welcome, Dennis. And next, we have Ning. Welcome, Ning.
Thank you, everyone. Welcome to our online meetup.
Welcome. And Ning has leading the development of the managed cloud service GreptimeCloud. He has over 10 years of experience in 2B and IoT fields. He has accumulated broad experience in developing time series data applications in mobile monitoring, new energy, and vehicle networking. Besides, he also has extensive experience in open source projects. Welcome, Ning. And last but not least, Jeremy. Welcome, Jeremy.
Hello, Vera. Welcome.
Welcome. He is leading the development of our open source time series database, GreptimeDB. He was a technical expert at Alibaba Tmall and Ant Group, responsible for the development of a unified solution for infrastructure monitoring. And he's been long engaged in the R&D of middleware and chronological database products. So welcome, Jeremy. And today's meeting is divided into 4 parts. First, our CEO, Dennis, will introduce who we are, what we are doing, and why we do it. Then he will talk about the designing principles of GreptimeDB, its flexible architecture, high performance, compatibility, and etc. For those who have been following us, you probably already know that we recently released GreptimeDB version 0.3. And our co-founder, Jeremy, will walk you through some highlighted features and what to expect for version 0.4. And finally, our CTO, Ning, will show a quick demo of our latest released GreptimeCloud, which is a fully managed database as a service for Prometheus backend. And if you have any questions in the whole process, you are welcome to type your question in the chat box, and we will take time to answer them after each section. And after all the sharing, we have leave some time for all participants to discuss anything interesting with us. And you can just unmute your microphone and discuss directly with us. Okay. For this is our first meetup, and as a special thank you to attend our meetup and connect with us, we've prepared a small surprise at the end. So all participants will have a chance to enter a lucky draw, and we will select 4 to give out our sweet swag. So make sure you stay us till the end. All right, so much for the introduction, and let's get started. I'll pass it to Dennis now. So, hello, Dennis.
Hello, everyone. I'm Dennis, and I'm delighted to be here today, share with our journey with you. Thank you for taking the time out of your weekday to attend our first online meetup. Your presence means a lot to our team. Wenjie, please, next page. Before digging into GreptimeDB, I want to talk a little about what is time series data and what is so special about it that made us design a database especially for processing and storing it. Well, compared to other types of data, the time series data, I think, has 2 main features. First, high volume, which I'll provide some data to illustrate later. And second, time dependency, which means every data point has a timestamp with each observation depending on the previous observation in some way. For example, stock prices are a type of time series data. The traders can quickly see the historical trend, maybe even make predictions based on a trade line. Observability is another example, is the ability to measure a system's current state based on data it generates, such as logs, metrics, and traces. Our team has previously successfully developed a TSDB, which relies over 100 million data points per second and requires tens of millions data points per second for system alerting and anomaly detection. The most well-known use case maybe is in the IoT industry. According to the Statista, there are 13.1 billion IoT sensors and 237 million connected cars in 2022. Let's do a simple math here. Assume each sensor collects 4 floating points every second, and each car produces 8 MB data daily. Then sensor data from 13.1 billion sensors will produce 13.1 billion GB of data annually, while 237 million connected cars generate 1.5 billion GB of data per year. Real-time processing and analysis of time series data requires cost-effective storage solutions. Historical data is important for accurate predictions. So, IoT's popularity has led to increase the demand. Wenjie, please turn to the next page. IoT popularity has increased the demand for real-time data processing, resulting in the adoption of TSDBs. TSDBs have surpassed other database in growth in the past 5 years, according to DB Engine's ranking. I think there are 4 factors that have contributed to this trend. First, the growth of the internet and the digitalization of many industries have led to the collections of vast amounts of timestamped data, such as website traffic, social media activities, and sensor readings. Second, the development of machine learning algorithms that were well suited for time series data analysis, such as recurrent neural networks and long short-term memory networks. Third, the rise of the predictive analytics has made time series data an essential tool for forecasting trends and making accurate predictions about future outcomes. Finally, the increasing need for real-time decision-making in fields such as financing, healthcare, and transportation has made time series data analytics crucial for understanding and responding to the rapidly changing business. So, after giving a history of time series data and its wide application, I will now tell you about my story and why we created Greptime. A few years back, I worked at a large fintech company where I was asked to build an ultra-large monitoring solution. I clearly remember the requirements even now because the team really struggled at that time. We spent months researching for a tool that fits our needs, but none of the tool existed at that time, which satisfied our needs. Our requirements are very hard to the nature of the business. As you know, in financing, a tool has to be stable and highly efficient. It needs to be processed massive, high cardinality time series data points at a reasonable cost, and handles at least 100,000 queries and write about 100 million data points per second in real time, as well as meet various high requirements for data analytics. These requirements cannot be fulfilled by a single database, as you know. So after doing extensive research about the existing products in the market, we decided to develop our own TSDB. And some of the great engineers I have worked with previously are also here today with us at Greptime. Greptime was built on an excellent foundation, even though we are still a young startup founded a little over a year ago. Almost all the team members are experienced developers with many years of working experience at big tech firms. We like to joke about how technical our team is by mentioning that our marketing team led Xiaoming. He is a very senior developer, and other marketing team members are either from engineer or scientist educational backgrounds. This team structure guarantees that we can quickly understand what our users want and communicate smoothly with the community. As many of you may already know, we are building a Greptime in Rust language. It was open sourced in GitHub in November last year. Since then, we have been continuously improving and adding cool new features such as dashboard, Prometheus supporting Greptime Player to help users visualize and get familiar with it recently. We released version 0.3. You can read the full article about it on the blog post. And Jeremy will also introduce some main features later. Other key milestones include the release of GreptimeCloud, which is a powerful database as a service platform, and users won't be worried about maintenance, upgrading, patching, all those not so fun but necessary operational jobs. Instead, they can fully focus on what matters the most, which is data and its business value. All right, sorry so much for the background information. Also, you may be wondering what's so special about GreptimeDB or GreptimeCloud like guarantees its high performance and the pay-as-you-go pricing model. I'll explain by walking through the architectural design and highlight features. Kind of remember, this part may be a bit technical. If you need to check some of the terms later, I'd recommend you to read our blog post on the designing principles. Let's get into the fun stuff. From the day one, GreptimeDB was designed following the principles of the cloud-native database, which means that it runs and takes full advantage of the cloud. First is the highly availability, which means on-demand computing resource with a goal to achieve availability and uptime rate of 99.39%. Second is the elasticity and scalability, allowing users to easily scale up or down, add or remove resources according to usage. Third is the highly reliable and fault tolerant, with the system having 99.49 availability rate to prevent data loss. These benefits are supported by the resource isolate architecture. To be more specific, the storage and computer are separated, as you can see in this slide, allowing each to be scaled, consumed, and priced independently. This is greatly increasing the utilization of computing resource, allows the pay-as-you-go pricing model, and avoids the waste of underutilized resources. Besides storage and computation isolation, different computer resources are also isolated for real-time analytics at scale with shared real-time data. Data can be shared among multiple applications without the need of competing at the same time. The next is the flexible architecture. With the flexible architecture designing principles, different modules and components can be independently switched on, combined, or separated through the modularization and layered design. For example, we can merge the front end, the data node, the meta server modules into a standalone binary, and we can also independently enable or disable the write log for each table. Flexible architecture allows GreptimeDB to meet deployment and usage requirements in scenarios from the edge to the cloud, while still using the same set of APIs and controller panels. So where abstracted laying and encapsulation isolation, GreptimeDB's deployment supports various environments from embedded, standalone, and traditional clusters to cloud native. GreptimeDB utilizes, please turn to the next page. Thank you. GreptimeDB utilizes popular object storage such as AWS S3 and Azure Global Storage Service to store large amounts of time series data, allowing users to only pay for the amount of storage resource being used. GreptimeDB uses adaptive compression algorithms to reduce the amount of data based on the type and cardinality of it to meet the temporal and spatial complexity transpond. As for high performance optimization, GreptimeDB utilizes different techniques such as a highly optimized LSM tree for time series data sharding, and column-based write log design to handle large workloads of time series data ingestion. The powerful and fast query engine is powered by vectorized execution and distributed parallel processing, and combined with indexing capabilities. GreptimeDB builds smart indexing and massively parallel processing to boost pruning and filtering. To simplify development and maintenance process, GreptimeDB provides Kubernetes operator, command line tools, embedded dashboard, or other useful tools for user and manage their database easily. Please check on our official website for more information. Several protocols are supported for database connectivity, including MySQL, PostSQL, InfluxDB, OpenTXDB, Prometheus remote storage, and high-performance gRPC. Additionally, SDKs are provided for various programming languages such as Java, Golang, and Erlang, and more to come with. We are continuously integrating and connecting with other open source software in the ecosystem to enhance developers' experiments. And after combining the matrix model and the rational data model, which is table, as you know, GreptimeDB provides a new data model we call the time series data. You can see in this slide, which presents data in the form of tables consisting of rows and columns with text and maps of the matrix mapped to columns, and enforce the time index, which represents the timestamp. The table model has a broad group of users and is easy to run. And schema is more convenient for users to manage and maintain. And it also brings enormous benefits for optimizing storage and computing with its information like data types, data size, etc. The SQL is easy to run and process association analysis and aggregation queries between various tables, as you know. Nevertheless, our definition of schema is not mandatory, but more towards the schema-less way, like MongoDB. Hope this quick walkthrough helps you understand what GreptimeDB and what we are doing in next. Next part, I will pass on to our co-founder, Jeremy, who is leading the development of the GreptimeDB to talk about our latest release, version 0.3, and future plans. Thank you, everyone. And thank you, Wenjie.
Thank you, Dennis. So let's pass on to Jeremy. He will introduce GreptimeDB for us. Hello, Jeremy.
Okay, thanks, Dennis, for the introduction. Hi, everyone. This is Jeremy. Please turn to next. Yeah, thanks. Let's jump right in. I will start by giving you some stats. In just a month and a half from version 0.2 to version 0.3, we have successfully merged 200 plus pull requests, carried out more than 120 features optimizations, and performed more than 20 refactorings. I must mention that we could not achieve these impressive numbers without the 27 contributors from our community. A big thank you to everyone for building this great tool together with us. Wenjie, can you, thanks. Now let's dive into the features of GreptimeDB version 0.3. Version 0.3 was released on June 7th. You might be asking, what sets it apart from previous version? Well, version 0.3's biggest difference is that it's a distributed version. This means that user can reap the benefits of its cloud-native architecture, such as scalability, high availability, and fault tolerance. Here are the main features. First off, version 0.3 now supports region-level fault tolerance. Fault tolerance ensures a workload to remain operational with zero downtime or data loss in the event of disruption. And this is achieved by the coordination among the meta server frontend and the data node. You can check out our blog about the internal design to learn more the role each of these three components play. Secondly, we've made a big step forward with distributed query optimization. GreptimeDB version 0.3 supports pushdown of most PermQL operators and mitigates the need of transfer a large volume of raw data, thereby improving efficiency. We also discuss this feature under the issue RFC distributed planner. The third enhancement is the procedure framework, which guarantees the ultimate consistency of multi-step operations. But remember, version 0.3 is just a part of journey, not the end of the story. We will continue to improve the optimize its performance. Finally, other enhancements worth mentioning include the addition of more metrics to monitor the operation of GreptimeDB, support for querying external data, importing and exporting files in CSV, JSON, packet formats, support for TQL explain, TQL analyze classes to analyze PromQL query performance, improvements in PromQL compatibility, and support for enabling Tokyo console. In summary, version 0.3 is a key milestone. It signifies that GreptimeDB is transitioning into a distributed version. Its right performance either matches or slightly exceeds that comparable mainstream databases. Stay tuned. We will be sharing the benchmark report soon. All right. That's about version 0.3. So what can be expected for 0.4? In a nutshell, it will focus on three main functionalities. The first functionality is supports distributed DDL elements like create table, job table, etc. This will be connected to the procedure framework to ensure correct execution of distributed multi-step operations. The second feature we are working on is async recompression and indexing to improve query performance. Last but definitely not least, even though in version 0.3 we supported most operator pushdown and predicate pushdown of PromQL. Version 0.4 will focus on pushdown of common operators in SQL. This will not only improve SQL query performance, but also keep focusing on user experience. Okay, that's all the big news about GreptimeDB for now. Next, Ning will show a demo for GreptimeCloud.
Okay, thank you, Dennis and Jeremy, for the wonderful sharing. So now we are going to invite our CTO, Ning, to show a live demo show of GreptimeCloud for the first time. And as we know that we have recently released GreptimeCloud, which is a fully managed database as a service for users to manage Prometheus backend data. So after the demo, all participants have a chance to enter a lucky draw, and we will select 4 to send out our gift swatch. Okay, so next, now I will pass my screen to Ning.
Thank you, Wenjie. Thank you, Jeremy. Last week we launched the GreptimeCloud Tech Preview. GreptimeCloud is a fully managed service built on top of our open source GreptimeDB. In this release, we introduced a Cloud Prometheus backend for users who relies on open source Prometheus for their application monitoring and performance analysis. Enhancements are also added to our database layer to improve the usability and the reliability. And today I want to walk through our cloud console and the data dashboard UI with you. So let's start from creating our first service on the platform. Yeah, first we can give our service a name. We can generate a random name. I'm hitting the button. Okay, solid ladybug. Oh, good name. Yeah. Second, we select a region for our instance. At the moment, we only have one region in AWS Oregon region, which is located in North America. As our user expands, we will create more regions in maybe Asia Pacific or Europe. The default plan is a free plan for our tech preview phase. It's enough for our user to evaluate our service. So hit the create, we will spin up a new instance on our platform. Okay, so let's check what's inside. Yeah, in the console you can see the connection information. I know some of you may have contributed to open source GreptimeDB, so you must know we have a range of protocols and open source clients that to integrate with the DB, and they are all available with our cloud. You can say that if you come from a Prometheus background, you can copy this configuration, and your data is automatically written into our service. And if you come from other background like application development or SQL background, you can find other tools you're familiar with. We want to make sure that the hands-on experience is smooth enough for you. Okay. Okay, let me switch to my own instance because it has already set up some data source, so we can see it more clearly. First, you can see the traffic visualized as like this. It's called the WCU, stands for write capacity units. It's an abstraction we designed to measure our write traffic. Basically, one WCU is for the one row you written into our database. As you know, our service is based on a serverless architecture, so we don't expose you the underlying server concepts like CPU and memory, which always has a boundary in terms of scalability, and it's indirect to your workload. For more information about the WCU and the RCU, you can check our docs. So let me open our Prometheus Workbench UI for more information. Okay, basically it's a Git repository designed to host your Prometheus configuration. If you come from if you have already set up a Prometheus instance, you have rules and configuration files. You can check in to the Git repo, and you are all set. Your rules are automatically evaluated against the data you stored on GreptimeCloud. But if you are new to Prometheus, you can create your own rules and the dashboard using our UI. Our dashboard UI is designed for simplicity and speed. We want to create a UI as fast as possible. So let me create a dashboard from here. We can select a simple matrix. The most simple one is load. And we hit this button, you can see the load is visualized. And for some of Prometheus metrics, they are accumulated. For example, network bytes. We want to select a device, filter it for this device. Yeah, for this cumulative metrics, you may want to visualize its rate. So we can select the rate here. So it's visualized, and you can still do more with memory. Or disk. File system. we want to make the process as fast as possible, and you can still edit this expression to customize it. So let's hit the button to save the dashboard. And your dashboard is actually a set of Prometheus compatible rules. You can use the Git repo to clone it into your local file system and edit with your own favorite editor, or generate from your script. You can further configure the alerting rules. For example, we want to alert when the load exceeded 10. Yeah, you can configure alert destination to your original alert manager, or directly to Slack or other destination. Yeah. If you are a power user of visualization and alerting, you must have been using Grafana. Here you can export this dashboard to Grafana for further customization. So, so that's what I want to demo to you. I hope you enjoyed this demo. You can always try out our service at GreptimeCloud. We'd love to hear from your we'd love to hear from you for your feedback and use case. So thank you very much. I'll give my screen to Wenjie.
Okay, thank you, Ning. So what Ning has just demoed is our latest released product, GreptimeCloud, and you are highly welcome to try it out at GreptimeCloud.com. Also, you can see our latest blog on our website about the detailed designing principles and architecture behind it. Also, you can join us through Slack to ask and discuss anything interested. So now let's come to our AMA Ask Me Anything sections. If you have any question, you can raise your hands, or you can type your question in the chat box and we will take time to answer them. Okay, any question? Yeah, feel free to type your questions in the chat box, or if you want, you can also raise and unmute your microphone. We can discuss together directly. Okay, so let's wait several minutes to see if there's any question here. Okay, so if there's no questions for now, we can you can always reach out for us at Slack, or email us at info@greptime.com, or you can follow us in Twitter, LinkedIn, and etc. Okay, so now let's move on to the last but most exciting part. Okay, I will pass my screen to Xiaoming, and he will see who's the winner of today's lucky draw. Okay, here we entered all participants for today, and we have prepared 4 gifts, Greptime, swag, and let's see who's the first winner. Okay, congratulations to Yang Yang Miao. Okay, so for the winner, you can leave. You can stay with us after the section ends, and to make sure we got the correct email address and shipping address for you. Okay, let's see who's the next. Okay, congratulations. Congrats to Lambda. Yeah, you are the second winner for today's lucky draw. Okay, since we don't have a lot of participants to enter, there's a high chance of winning this lucky draw. Okay, here comes our third one. Congrats to Xinjie. Okay. Okay, let's see who's the last one. Who's the last winner? Let's get the wheel rolling. Okay, it seems that nada. Okay, congrats. Okay, that's all for today's sharing, and congrats for all the winning.
There is a problem in the chat room.
Sorry?
There is a problem. Somebody
there's
sent me
a problem.
question. Yes, somebody sent me a question.
During the batch query process, is there a problem that the server I/O is too high, or how do you plan to solve this problem? Okay, so
this question.
Yeah.
I think the question is about the I/O between the data node and object storage such as S3. I think the problem is this, and we have designed a cache layer and a buffer manager system to keep the recent almost 1 week data in local disk, and just to avoid fetching data from object storage every time. So this buffer and this distributed buffer and cache system is not ready yet, and we are still in still write RFC for this feature. And if you are interested, please keep attention to our repository. Sorry. I think I don't know if I answered this question correctly. Or Lin or Jiachun have to other answer.
Yeah, I saw the question is from Xinjie. So I'm not sure if this answer a question. If not, you can directly type your question in the chat box.
Yeah, it's just like the architecture in Snowflake, and with a consistent distributed data cache, and that's the common solution for computer and storage separation architecture. Yeah.
Okay. I think Eugene raised hand.
Yeah, so let me see if I can. Okay, I cannot share my
we
screen, unfortunately, but yeah. Hi everyone. Yeah, thanks Dennis, Jeremy, Ning for the demos. Yeah, I'm curious, just a question to all of you actually. If you had a magic stick, what would be the feature that the next Greptime DB release would be included? Just any feature, like, you know, with magic we can just dream about anything major. So yeah, I'm curious which type of functionality you would include.
Do you mean by which functionality will be included in our next feature for next version for GreptimeCloud?
Yeah, but it doesn't have to respect the timelines or like the efforts. But yeah, just the major, I don't know, just deploy across all available cloud providers or something like that. So something along the lines. I'm curious.
Sure, maybe some major milestone for GreptimeCloud, major key features. Could Ning take this?
Okay. Thank you, Eugene. First of all, our highest priority is to improve the performance. During the next release of our GreptimeDB, the 0.4 release, we are going to improve the read performance a lot, and we want to port it onto GreptimeCloud. And for GreptimeCloud, we will expand our regions into more locations like Asia Pacific or even in China. We are also building some integrations with other applications, other data sources like EMQ. It's a message queue that widely used in IoT domain. And we are also working with a team from Datadog called Vector. It's an agent to collect information from various data sources like Prometheus, InfluxDB metrics, logs. We can make it even more easier to ingest the data into our database and also as well as cloud. Yes, I hope this has answered your question.
Yeah, absolutely. Thanks for sharing.
Okay, thank you, Eugene. It seems that we do not have any unanswered questions. So I think that's all for today's meetup. Thank you all for participating. And we are looking forward to see you again soon in our next meetup. Okay, thank you.
Thank you, everyone. Goodbye.
Thank you. Bye.
Bye-bye.